This
Today's session
conference will now
is
be
about
recorded.
introduction and design challenges of design. So first, I'm going to explain what is a out 5G, just giving the structure. Then what are challenges we are facing in 5G systems? Then I incorporate or explore how these challenges have been solved by using visual sim. And I'm also going to show you some of the exciting examples and demo models of realistic 5G applications in practically in visual sim. And then I'm going to talk a bit about libraries and analysis tool, which is available in visual sim. Then at the end, I'm going to give some open challenges that we will face in future and how visual sim is challenging, like towards focusing towards those visions and how it's overcoming those challenges. I'm going to talk about that. And then finally, I'm going to brief the about design. So this is about today's agenda that we're going to see in this webinar, and it's going to be very, very interesting. Let's go into the topic now. So it's about introduction and design challenges of 5G system. Well, first, before going into explain you the 5G system, I will show you how 5G scenario is complicated in a realistic way. In future, if the 5G is coming up, like how the model will be in a realistic way, and how it's going to be very complicated. So I'm going to focus on those right now. So what is 5G? I have a question about that. So putting into very simpler terms, it's a next generation wireless transmission. And what is the key speciality of that? So we will all think, okay, 5G. So what is the key speciality? We also need to think about that. The key speciality of 5G is to bring the humans and the machines to work closer. So there are three main use cases. The first is about ultra low latency. The main is about and focuses the application focus of this use case is autonomous driving and robotic surgery, where the network should always be communicated to the machines in a millisecond latency. So it's a very major application and the use case of 5G. Then you can see the another main use case is ultra fast data transmission, where here the person tries to download a high resolution video, or if you want to play or experience the virtual reality gaming, then 5G also support. And third main use case is about mass emission capture. One of the interesting applications are smart sensors, smart homes, smart parking, etc. So this is a very current research putting forward the IoT in an application-oriented way. Examples are interesting. So in this structure is very, very complicated, right? So you can see it deals with the radio resource management, it deals with the mobility management, it deals with the vehicular communication, it deals with the drones, it deals with the company. So it brings or it collaborates with each and every the quality of service. So what are the new requirements of this? So first will be new physical layer architecture. So we will from the baseband from generation to the receiver reception, we will have a new system modeling and architecture modeling and new net architecture. It's not going to be just a physical layer. It's going to collaborate from the physical to application layer. Then new design approaches for ensuring quality of service. We are working with the models like antenna models like beam. So and forming, we need to have beamforming. So So those are the new design approaches. And then we have a new platform for testing. So because we can't directly put real time model and to test with various diverse performance metrics in order to go real-time applications. So the requirements of 5G. Now I'm going to show you some of the design. So I already discussed some of the challenges, like we need to have a new design architecture. That's one of the biggest challenges. And next thing is about is a complex, going to have a complex structure. Because we already have the models for LTE, and it's going to be very, very advanced in order to optimize the performance. We're going to have very complex and innovating design models. So we need to have advanced models, receiver models. So and also we need to think about channel models. These are the basic design challenges that 5G will face. And something we need to think about is the time factor, considering factors, performance, and then the budget. Two things to put forward in allocation. So these are the time implementation. So going on now, I'm going to explore and going to take forward you, share how Visual Sim is going to put forward. So this challenges into the goals. The Visual Sim platform is give us a platform for system. So you have a system model. Okay, you have a system model, and you plan to design. So you can directly put according to. I can directly plug those models in the Visual Sim simulation and explore various diverse performances matrices. And second most important from the baseband wave generation to the antenna model. So for example, if you are designing a beamforming antenna, okay, so at that moment, so you don't need to wait up till RF chain, up to the transmitting RF chain. What you can do in Visual Sim is you can explore those things in each block. So it's an algorithm written, so you can evaluate those algorithm in the block wise. So that's one of the interesting characteristics available in the Visual Sim. And the important thing the Visual Sim provides you is about trade-off. So we want to, in order to optimize the performance and to showcase the performances, our reasons, we need to have a trade-off. So for example, if you are designing the antenna range, or if you want to see what if we change the frequency, or what if we increase the diameter of the range of the antenna. So what will be the performance of those? So we can do it in a graphical method in Visual Sim. That's the most important characteristic that we have in Visual Sim. And finally, we do ensure design standards, and we can share the models to the development team and product development team. So these are the 4 main goals that Visual Sim put forward in front of you. Now, so we discussed goals. Now I'm going to show you how Visual Sim is going to work and is going to focus how it's giving a solution for this design works or design challenges. So first thing, it's going to be a multi-domain modeling. It's not going to be block-wise modeling. So you can integrate, you can collaborate, you can bring the hardware, the software, or the software platform for the performance. So basically, it collaborates with all those to bring out application-oriented products. So it is one of the main solutions that Visual Sim. We will have an end-to-end view. So for example, it's not just going to be the physical layer architecture. So it's going to range from physical layer architecture to the application layer. So when you design or you integrate in Visual Sim, actually where the message is, like what the block is doing, or how the messages should be transmitted. how is the performance of those blocks. So you will have an end-to-end simulation and other various performance matrices or various statistics that you can obtain by using Visual Sim. Then it's going to be ensure timely delivery, and it's with a high performance, high precise performance with optimization design models. And finally, it's you can generate documentation. So you design a model, you want to uh, you want to transfer the knowledge to the development team or product development team. So you need to have a documentation, right? So at the time you want to spend some time on that, but the solution of Visual Sim makes into seconds. So I will show you a demo of it, like how you can generate the documents in seconds. So let's see. For example, if I take this model, so this is the block where I right click on this. So there will be a documentation. So here I get documentation. So you will get the full information of the block. So you know what the block is and what is really happening in the block. So this is exactly like you can transfer those design what information to the development team in seconds. So that's a very interesting thing that Visual Sim. These are the solution that Visual Sim does. So right now, I will give a pass for you guys to think over. If you have any questions, you can type that in the chat box. I will directly answer to that. Okay, so we carry forward with the slides now, and whatever questions you have in your mind, you can type that in the other section complaints. I will answer to those questions. So right now, I'm going to explain or showcase you what are the diverse performances matrices that Visual Sim provides in a 5G case scenarios. So Visual Sim does, you can calculate throughput calculation. The gain is a very important thing. So it calculates throughput. You can get the throughput value, and you can get the performance of matrices of power. Then you get the timing structure, like how much. So you decide. So you make a model, and you think that it should come with this amount of time. So it need to. So you have a pre-structure evaluated timing. So you can model and you can also evaluate and get those informations using Visual Sim. So timing parameter is also will also be, and the latency you also can calculate using Visual Sim. Then it's going to be bit error rate and handover rate. You can also calculate handover rate and then outage probability. So these are the diverse performance matrices when you design a model of 5G, like 5G. So these are the various diverse performances matrix that you can able to attain or achieve by using Visual Sim. Okay. So now I'm going to show you the basic exploration of simple wireless network. So this is just a simple basic understanding before going into your complex structures. So you will have a transmitter ORF chain where you do the waveform and then you modulate it, code it, and then put it into multiple access technologies like OFTM or NOMA technologies, and then power amplifiers. And then it is transmitted to the channel. So you construct the antenna. So it can be a massive MIMO antenna, and it can be a beamforming antenna or beam steered in order to attain the quality of service. And the channel model, you can construct or think about the channel model in the 5G scenarios, because if we have a lot of interference and fading incoming, so we need to clearly think about and for designing the 5G structure. So this, and in the receiver side, we always going to decode what and all thing. So over here, as I said in the previous slide, we're going to have a performance matrix of bit error rate. side. So you can calculate how much error is happening in the receiver side. So you can practically see these things in the visual sim and digital demodulation and physical reception. So this is the general and basic idea of how the wireless is working. And right now, I'm going to address uh, how the wireless is challenging by using challenges, facing the challenges by using various diverse performance matrices. So right here, so you can see the exact structure that the wireless simulations are. So in the basic model, we have a generate baseband waveform where you generate the waveforms, and over here it comes to baseband precoding. Over here, you design your own model. For example, you can think for massive MIMO or hybrid beamforming. You design accordingly. You don't need to wait up till the end of the order chain. So what you can do is you do the algorithm in the software, and you can listen to the blocks and evaluate those performances. You don't need to wait until you complete the transmitter or off chain. So you can evaluate each and every performances, algorithm performances in each and every block, and then it moved forward to digital to analog and then RF chains. Over here, if you want to have a trade-off or you want to check what if the power is being different? What if we give the power as 10 megawatts, like 10 watts, like that? So you think about it. You will think about and see the trade-off explorations over here, and it's been transmitted to the channel, and the channel over here, it's a receiver side, it's combining on the receiver. The receiver, you can find out the imperfections and explore these performances matrices like delay, bit error rate, throughput, power. It's not limited to these performance matrices. We have a wide range of performance metrics you can explore by using histogram plotting, bar graph plotting, or you can find out the latency. So this is one of the how the whole physical block is working in the visual sim and what you can achieve in each and every block. So this slide is exploring that. So right now, I will give again a short pause for you to think. If you have any questions, you can just drop in the chat box. I will answer to the questions. So, okay, we can move forward with the slides. So from now, I'm going to show you how the models like exact 5G scenario cases has been developed in the visual sim. And I'm going to showcase some of the interesting demo, application-oriented demo models right in front of you by using visual sim. So first, what I will do is I will tell you how it's been designed. So I will explore you, I will take you with me by exploring the system architecture. Okay, so first understanding of system architecture, then how it has been translated into visual sim, and what and all data statistics we are achieving. So I will take you step by step so you will have a clear idea about it. So right now, this is just a framework. So what do you think? What you need to do? You think about your model and you put into blocks and integrate softwares and algorithms and design into one structure. So constructing of network model, then you define the parameters. For example, how the message should be transmitted, in which frequency it needs to be transmitted, and how much in which power, how much power it needed, or what kind of delay or what kind of scheduling is being done. So you can define all those parameters in the blocks, and at last you can measure those response time and the network utilization by getting all the data statistics at the final result just in one go. That's very, very interesting. So right now I will explore you the system architecture of MIMO model. So first, a basic OFDM architecture will have scrambling, encoding, then interleaving. So over here, the interleaving has been included in order to improve the performance. For example, if we generate a random bits and put into the array of structures, and in order to reduce the bit error rate and giving the high performances in the receiver side. So just block and the mapping, then we are doing the OFDM functionalities here, and then over here we are saying here the preamble. So we are giving all the informations. So which receiver you should need to go. So we are putting all those informations into the packets, and those packets are sent to the receiver side, or others decoding is done, and then over this. So in here, what is interesting is, so we use 4x4 multiple input antenna. So over here, the 4 input antennas transmit the messages, and over here, 4 output reception antennas receive those information and carry forward. So this is the MIMO OFDM system architecture. So right now, what we're going to do is we're going to exactly replicate this model into visuals. So you can see it. You can see exactly. So you can see exactly the system architecture put it into it. So you can see bit scrambler, we're using LDPC channel coding, then interleaver, then we're using modulation, then OFDM we're using, then putting into massive MIMO. So this, we are exactly replicating the system architectures into it. And right now, what is the important constraint here is we're going to find out the latency. So that's the important parameter of 5G. So over here, we're giving the input of the demodulation to the channel coding. So over here, it will have the information periodically, like beforehand, so it can improve our performance too. So in this model, so I can tell you like a story. So for example, if you want to send a message from a mobile to the base station, then from the base station to the reception, that's what here it is happening. So we're going to see at what location at the base station, so what latency, in what timing the package is being received. And in the reception side, what in the reception side, so what latency we are attaining. So I'm going to show you the model in the visuals right now. And so this is the model where you put in the parameters over here and build this model. So over here, if I run this block, you get various performance. So here, the main aim is to find the latency. So in the first base station of the reception of messages, so it's getting plotted. So let me finish it, and I will explain you what really is happening here. Okay, so right now we have various statistics over here. I will maximize this and show you. So where here you can see at what time information has been received. So at what time the message has been processed, and you can see the bit frame over here and the block, like traffic block we have, and then the delay, how much delay it's happening. And we also have IDs. So you can use these IDs in order to particularly spot out those information for the plotting. So this is and then over here we have a time array. So we have various times, and so it does calculate the latency, the efficiency over here. So that is going to be this box. So this is the reception, latency reception of the base station, and this is the device reception of the messages. So where you can see the latency is less than millisecond. So where it goes high can sometimes, but it comes to optimize to very less latency. So over here is also it very less, and sometimes it does spikes. So this is how you can explore various informations, latency informations by using visuals and modeling. Now, so going to slides now. So here it's the same thing which I've shown you in the practical way, and I also showcased when I run it and how it's been generated. You have seen it. So we're moving forward with the interesting application-oriented demo models. So this is a block type model. So now we're going to integrate with applications, considering of real-time situations, like taking the account of real-time situations and how the model is going to work. So right now I will finish this topic and give it a short pause. So if you have any questions based on this, you can also type in the chat box. I will explain after completing this section. So first application-oriented model is a broadcast pattern using various sensor node. So let's me go to the visual sim. So right here you can see the model here. So I will give a short brief about this model. So this is a receive, this is the transmitter. It's going to send the informations. So these are the various range of antenna ranges. So we built a various range of antennas nearby. So what is absolute actually what is going to happen is this transmitter is going to send the messages periodically. So in which orb the antenna is going to get. So while I run it, you can have a better understanding. So I will run this, you can see. So over here, you can see the red one. So I'll run again and explain you. So let me take this here. So exactly what is happening here is, so this transmitter is sending the informations periodically at each time interval, okay? So now, at first time interval, these antenna ranges very near to this transmitter receives it, okay? But some of the antennas which is very far from the transmitter will is able to receive those messages in the maybe in the second hop or in the third hop. So it exactly finds out like in which hop the number of nodes receives the information. So it's a one of the application. For example, I will show you a trade-off here. So let me minimize this. So for example, this is the range of antennas, right? So I'm going to change the range of this antenna and I'm going to showcase you what is going to happen if I change it. So over here, I'm going to change the range of the antenna. So let's put 200 and here 500, here 300 to 600. Okay, so I'm ranging the antenna route. Let me commit and now let me play this, run the simulation. So right now you can see the range of antenna is being moved. So here, this you can see various trade-off now right now. So before it was more in the third hop. Right now, when the range of the antenna is moved, first in the first hop, only these two antennas are able to receive those messages. But all these maybe in the second or third hop is able to receive. So you will have a range like putting into you can bring the real-time models and see what really is happening. So it will be easy for real-time implementation. So that's what I want to show and also show you the trade-off. So going to back to slide. So another important model is about considering the interference. So over here, I will give a short demo of this too. Uh, Okay, so this is an interference. For example, considering a terrain, in the real time, you can consider that as an hill. Okay, so you can consider that as an hill or house. So that's kind of interference. We need to consider that. So if it's just a graphical thing, where you can see this is a transmitter sending the receiver. So what is the main aim of this model is to plot out the power, how much, like if the receiver is moves around this sender, okay, if it moves around, when it receives the signal, when it so it calculates the power and put it into, we are going to put in the polar plot. So let me run this, you will have a better understanding. So over here you can see the receiver is moving from this place, okay. So when it moves here, it comes behind the interference right now. So see, the messages could not received by the receiver, and the power of the message signal is 0. So it comes to the 0. So its example is just putting a model of interference model. So it exactly replicates of a real-time situation what will happen. Uh, this is another interesting model. Um, Let me go to slide again. You can you can tell me whether the voice is clear right now. Can someone can confirm? Uh, can you hear me properly? Because I got a message that the sound quality is very poor. Okay, let me go to the topic again. So the another interesting model is the smart parking. So it's a very interesting one for the machine-to-machine communication. For example, if you're having internet connection, then you can retrieve the messages by using GPS. But when you're in offline, then this scenario comes into a very interesting thing. So the sensor collects the data and transmit that to the antenna, and the user can get into applications. Let me show you demo mode of this. So, so can you see here? There is a various lot of range of nodes, sensor nodes are available. So when the car comes and occupies here, okay, the sensor tells, oh, okay, the car is right here, and the user can park the car in another slot. So it stores the information, and those information is being modeled by using the channel, like we constraining the channel here, and then it's going to transmit those into the wireless, and then it's going to be sent to the user as application oriented. So he knows where we can park the car. So I will run the simulation. You will get an understanding. So over here you can see for every time interval, So for every time interval, for every second it calculates. The car comes in and if it comes in, it says one. If it comes in, it says if it comes if it goes out, so it stays as zero. So it stores all this information and it been transmitted. So this is one of the interesting model, and it's also this is one of the very interesting model, and it's in the research purposes also. Let's move into the next another model. So right here, what is the real purpose of doing this? So how it has been done? So it's a 5G how end-to-end simulation is done. So for example, if it's first thing you need to have a research, like what model according to the customers or user specified applications we need to work on them. So you both discuss and come to your requirements. So these are the requirements I need, and I need this much of latency, and how much this much of optimizing performance, and this much of throughput gain we need. So you plot those requirements. Then we're going to design that in the visual sim. So you design various antenna RF components and this one. This is just a physical layer, but we can also integrate with the network models. For example, we can come up with the Ethernet and then putting these physical layer into Ethernet models and work up to the application layer. And then it being implemented or integrated. The algorithms are being integrated in using Java and C for the performance evaluations, like the latency for the latency purposes. Like you can also use various platforms for integration. And what is absolutely here is test from the top model, from the top block to the integration. Okay, so you decide performance up to the integration. At each and every block you can test the algorithms and you can come up with the evaluation parameters. So in the, for example, if your requirement is to bring to a very less latency, you design on those models. So when you design these algorithms itself, so you come up, so you can evaluate, you can come to the point, you can know, you can actually know, okay, when I design this model, this much of performance is happening. So you know for each and every block. So according to requirement, you can optimize the system. So this is a very important thing that Visual Sim does from the end-to-end simulation. So this next in the next slide, uh, there is another two interesting demo models I want to showcase you. Uh, so over here, so let me close all this. So over here, so here the has here the cell is being designed with the faced in the 8-element beam steered antenna. Okay, so what it's going to be done is the receiver is going to move around the center. So this is beam steer. So how it's designed, you can see the beam steering is like this. So it points out the main lobe directly contact with the user. It will have a direct contact. So like this, we designed a 8-beam steer antenna. So that's what it does. So it designed like that. So the receiver going to move around the center, and we're going to plot the power. So how the receiver get the information. So when I run the simulation, you can see in the graphical way. So over here, the receiver moves around. So the power received to the receiver is plotting in the graphical manner, and you know if there is some interruptions or interference happening, you can just know whether the receiver receiving the information. So it's a very interesting that to make it into graphical and see how this works. And this is an exact scenario that you can put into real-time system. So this brings you or this explores you to exactly to know what is happening. So let it finish this. So the receiver moves and the power plot is plotting. So over here we can conclude that the 8 beam steer antenna is directly having a contact when the receiver moves around it. So that's why the power received to the receiver is always having a contact. So yeah, so this is how. So you can see the power is being plotted over here. Okay, this is one of the application oriented of antenna demo beam steer antenna model. Let me go into the slides. Okay, I wanted to show you the very important parameter here. Here is experimenting with the power and accelerator. So here we also do trade-off with the power. So what we done is we have a software implementation over here, and we have hardware, home system, and we have here bus topology, and we have SDRAM, we have connected flash, everything. So the main target is being achieved here is the power. We determine the power should be less than 1 watt, and the frames should be greater than 30K. So that is the target that we design, we think in the mind and designed in a way. So what and all we did, the mathematical things we did in the handwork. So exactly we replicated in the visual sim. And what visual sim did, it exactly given the accuracy. So if you see in the next slide, that in the spreadsheet, where you can see uh, in the spreadsheet, you can see the average what the average where this is a very minimum average what we have targeted and we have achieved it. So I will directly go to the visual sim and give a short demo on that. So this is the base and this is a software. This we connected integrated hardware here. So let me we have power management everything so connected. So let me run this simulation. So we got a lot of different statistics performances here. Uh, various diverse performance matrices. So we have timer plot. So for instance of time, we are plotting here. It's running, it executing. Let it finish. So over here, we are getting the instance for instant of time. How is the power? So we can also get those informations too. So over here, you can see for this instant of time, for this 0 time, however the power is, it goes to 1.35. And for this instant of one at the one time at the timing 1, what is the instant of power? So these all informations we get. Still executing. So let us go to the slides. So now what I will do is I will show you a trade-off here. So yeah, this is what I wanted to showcase you. So over here, we see the instant of time in the another plot. Over here, this is the average power plot. So what is the target? So we fix the target. So it goes, the average is less than 1 watt. So we given and the accuracy of the model is exactly the same. We get the performance accuracy like 99% over here. So this is just a software model. So what I'm going to do is going to integrate it with the software. So I'm going to change the parameter here to hardware. Okay. So now I'm changing that to hardware. Now let's see what just happens. So let me close all this so you will know. Okay, so let me run. So now we are integrating these on and all this SD-WAN flash, all the software, and considering how the power it will be. Like now we're making a trade-off, how the software works and how much it will be the power. And now we are integrating the hardware and going to see how much power it's going to consume. So let's make a trade-off now. So let's me run the simulation. So over here we can see already we can see there is a lot of spikes by using the hardware. So we can know so what happens if we integrate hardware, like how much power it's going to consume, and let's see what is the average thing. So I will show you the average one. It's going to be much interesting. We can making an actual trade-off between the software and the hardware over here. So before simulation, I just ran the software. Now I integrated the hardware. So we have different performance metrics like power usage, like how much power it takes. Like we have all those informations. So and here we got all we are getting all the statistics. So here we also for all the timely for particular time instance power how much we are getting spikes. So we get all this information. So 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 compare. So already I shown you right. So before how much the power was very much minimum when we use only software. But right now when we integrate hardware, we see some spikes like average power has some spikes with the power. So we can actually calculate all these things and put into we can get a overall view of what we are doing. So just wanted to show you this power trade-off. Now going on to the slides now. So yeah, so I will give you a pass. So if you have any questions, you can type that in the questionnaire. So I will try to answer. Okay, let me continue. So yeah, I'm going to speak a bit about the library models and the environment which is applicable, which is available in Visual Sim. Here you can see there are a wide range of library models available in Visual Sim. So I'm starting from traffic, networking, 5G model, integration of hardware, FPGA, everything. We have an overall view and overall library models with the diverse library models available in Visual Sim. So right now I'm going to discuss some of the open challenges and the emerging challenges and how Visual Sim is focusing on that. Okay, so let's go. Okay, so let us think. So I already shown you the figure in the previous slides how 5G is going to be very much complicated. Yeah, so in the future we're going to have the heterogeneous network modeling. For example, we're going to have large base stations, small base stations, and we're going to have a Wi-Fi. We're going to have all those parameters in one range, right? So we need to ensure the quality of service should be considerably good for the users who is inside the range or who is in the edge of the range. So the quality of service should be very much important in these cases. And we also the another open challenge is about the channel model. So how are we going to think about the channel model? So in the 5G scenario, is a lot of interferences will be there. So how are we going to think about that? These are the main challenges that we need to focus. And right now, I'm going to talk what are the focus and the improvements that Visualsim is giving a vision towards these challenges. Okay, so I'm going to, our first thing is we are working on or we are going to improve with a very lot of performance matrices. For example, I just shown you the hand of with a power trade-off and those things, but we're also going to consider or going to improve with the handover rate, or we're going to showcase all the bit error rate. So it's going to be the very much diverse. So you get the information, various set of informations of the design model when you just when you just run a simulation. So that's one of the thing. And we're going to integrate the software and hardware for the end-to-end simulation from the physical layer to application layer. We're going to integrate and see how it's going to work, how the latency is going to be, how the power is going to be. So we're going to calculate all the scenarios that is the difference, the major difference that we are showcasing in Visualsim. And we're going to collaborate with various IoT and telecom companies in order to provide into application-oriented products. For example, like smart analytics, shown a demo model about smart parking. It's an using of 5G scenario, 5G models to those applications. So we're going to improve, like we're going to make a vision for more and more application-oriented models with using the 5G scenario cases. That's going to make a boom into the Internet of Things. So this is some of the challenges. So finally, I'm going to give a short brief about the profile of mirrorless design. We company started at 2003, and in 2008 we got Stochastic Modeling Innovation Award, and we got in 2018 we got the best ESL attack and second on Decon. Right now we are supporting and giving services in major 4 locations, that is in US, Europe, China, and India. So we are all here for your success. Then there are in 2 different ways we are supporting. First major thing is giving training. For example, if you have a design model in your hand, or if you have a system architecture to be done, so we sit with you and work with you and tell you what need to be done. So we give training sessions to those people who are having their own model or to build their own model. And also, another main thing is about services. We also provide services. For example, if a company is asking, okay, this is a requirement. And what we do is we sit and discuss. The company and us going to sit and discuss and going to make out the requirements, what need to be done, or what application need to be done, what product need to be done. So we work together and to bring out the product. And on each and everything, we're going to evaluate the performance, what are with the requirements, and optimize the performance according to the customers. So we work on these 2 major info things. And the general core idea of Visualsim is one is library, and then graphical modeling, then hardware, software, networks. So these are the core ideas about the model. And it is going to be integrated with the timing and throughput, then power management and battery, then NTRE, semiconductor. So we collaborate all these performances metrics and also with all these explorations, so which leads to the whole solution of visuals. So what will be the engineering benefits? So the major engineering benefits would be if you think about a model, for example, if you want to design a model, if you think about a model that will take for 3 months, but if you integrate the visual sim and do, it can minimize into days. That's the major impact that the visual sim is trying to give. So you can see all the analysis in the report that you can able to do here. So for more information about the models, the demo models availability, the white papers and webinars, you can always go to www.mobilisdesign.com Visual Sim, where you can able to find what you're doing and what products you're doing, and you can always contact us for your support, and we will be there for you. And the web search, you can also do Visual Sim in Google, so you can find out more information. And finally, thank you very much for your patience listening. If you have any queries, you can just type in the chat box. I will try to answer those questions. Even in future, if you have any questions, you can directly contact us. We can help you.